This is numbers 21 through 24 on the Unit 5 study guide. Number 21 and 22 say that we're supposed to apply the transformation, then name the new coordinates, and then we're going to identify and describe the transformation. What I see here, again, is a translation. And so what you're going to be doing is you're going to be moving the x left 1, and the y is going to go up 2. Now, if we're going to apply this rule, basically, we're going to take 1 off of the x. So my new a prime, if I do 3 minus 1, that gives me 2. And it tells me to add 2 to the y. So 10 plus 2 is 12. Now, let's do the b prime. We're supposed to take 1 away from the x. So it's negative 6 minus 1 is negative 7. And then we're supposed to add 2 to the y. 4 plus 2 is 6. C prime. We're supposed to do negative 1 minus 1, which is negative 2. And then we're supposed to add 2 to the y. So negative 4 plus 2 is negative 2. So let's go ahead and plot these new ordered pairs. So we have negative 2 comma 12, which would be kind of up here. Negative 7 comma 6. 1, 2, 3, 4, 5, 6. That's my b prime. And then negative 2, negative 2, which would be my c prime. So kind of like a shape up here. Sorry about it, fell off the graph. And now we identify and describe the transformation. So this was a translation, left 1, and up 2. On number 22, I can see I've got a dilation because we're multiplying both the x and y by 1/2. So to find a prime, we're going to multiply 1 by 1/2, which makes it 1/2 or 0.5. Negative 3 times 1/2 would be negative 1.5. Let's do b. Half of 4 is 2. Half of 1 is 0.5. And let's do c. Half of negative 2 is negative 1. And then this negative 1 times 1/2 would be negative 0.5. So let's go ahead and plot these. So we got 0.5 comma negative 1.5. Right about there. That's my a prime. I've got 2 comma 0.5. Right about there is my b prime. And then I've got negative 1 about 0.5, negative 0.5, which would be right about here, c prime. There's my new figure. And now let's go ahead and describe what happened. This was a dilation by a scale factor of 1/2. On 23 and 24, we're supposed to tell whether or not these polygons are congruent after we have done the transformation. If they are, we're supposed to describe the transformation. So what we want to do is plot these points. So negative 4 comma 1 is E. Negative 2 comma negative 1 is my F. And then I have 4, negative 3, 1, 2, 3 is my G. So let's go ahead and, ooh, this is a very slender triangle. Sorry about that. Now let's go ahead and do the W. So we have negative 1, negative 3, which is my W. And then I've got 1, negative 5, 1, 2, 3, 4, 5. So that's going to be my X. And then I've got this 7, negative 7. So 1, 2, 3, 4, 5, 6, 7. And that's going to be my Y. And let's go ahead and connect these. Again, cut that same slender triangle. You can double check by checking your slopes here. See how we're going down to over 2? And this went down to over 2. And then we went down from here. It looks like we went down 2 and then over 1, 2, 3, 4, 5, 6. So we're going down 2 over 1, 2, 3, 4, 5, 6, and it works. So since our slopes kind of show us these are going to be congruent, why? Well, all we had was a translation. It just slid into that place. All right, number 24, we're going to do the same thing, plotting our points. So negative 3, 1, that's my K. 1, 8, that's my L. And then negative 4, negative 1, that's my M. So another one of these slender going on. Almost looks like they're on the same line. Let me double check that they're not. They're not. So ever so slightly, there's supposed to be a triangle there. Now we're going to do this again. We've got negative 7.5, comma, 2.5. That's my t. We've got 2.5. So 2.5, comma, 20. Whoa, we're way off the graph. Somewhere way up here. And then we've got negative 10, comma, negative 2.5. So negative 10, and then we've got negative 2.5 right here. And so that would be my S. And so here's kind of what we've got going on. Same kind of ugly triangle. I wonder if a dilation actually occurred. So if this was truly a dilation, let's just kind of look at that slope again. Here I went up to over 1. Let's see what we got here. We went up from this point, just double checking myself, give me a second. Okay, so it's 2.5, so we went up 2.5 plus another 2.5, so that's 5 units over 2.5. So we really kind of have that slope that matches here if we're looking at our slopes. So you could check it again going up here and over. We could even do the slope formula on it, but I bet you this is a dilation on this. If you did want to check it with your slopes, then here's what you could do. Let's look at Kn, because that's what I was using before. So if we do y2 minus y1 over x2 minus this x1, let's find our slope. That gives me negative 2 on the top. That's going to be plus, so then that's going to be negative 4 plus 3, which is negative 1, which gives me a slope of 2. Now, let's check it to this ST. Here's ST. So here we've got negative 2.5 y2 minus my y1, 2.5, over my x2, negative 10, minus my x1, so negative 7.5. Sorry. When we have negative 2.5 minus 2.5, I'm going to get negative 5 on the top over negative 10 minus a negative really means plus. So we're going to be adding that 7.5, which gives me negative 2.5 here. Now when I do negative 5 divided by negative 2.5, I'm going to get a slope of 2 again. So again, that confirms that these slopes are the same. And so like I said, likely you could check the next set of slopes if you wanted to. If they're the same, you know you've got yourself a dilation here.